All right. So, number 19. So this will be for the final B. I've got to get these to cancel out, right? So it's all about factoring. It's the 5-step method every single time. Every single time. So the first step is GCF. It doesn't matter which one, if you're going to do all 5 steps, or maybe you only do 1 step. Like in this case, GCF. What goes into 5 and 40? 5. Perfect. How many times?
1 and 8.
And 8. Okay? Perfect. Okay? So basically, I have B plus 8 over 5 times B plus 8. Okay? Now, before I cancel anything out, I want to make sure I know what B cannot be. Remember, the bottom of an equation, the bottom of a fraction cannot be 0. That means this cannot be 0. Now, can 5 ever be 0? No, because 5 is 5. So that's easy. But what about B plus 8? That could be 0, right? So this cannot be 0, so B plus 8 cannot be 0. So what can you add to 8 to get to 0? Boom. It's not, at this point in the game, it doesn't take a genius to figure this out, right? At this point, by Algebra 2 and Pre-Cal, we should have this down. We shouldn't really have to be like, I'm going to minus 8 from both sides. No. It just shouldn't happen. You should be able to look at this and go negative 8. Right? Okay, good. And then move on. Cancel, cancel. So what's left is a 1. Don't forget that. Just because it cancels out doesn't mean, all of a sudden it's a black hole. Nothing exists there anymore. No, there's always a 1. It's just hidden. Right? 1 times this. It's just hidden. When that goes away, there's still a 1 there. So I'm going to be left with 1 over 5, whereas B cannot be 8, negative 8. So that's simple. We're done. Okay? What kind of polynomial is this? Because this is a polynomial, kind of, right? But not really, right? Because it's not a polynomial, because it's got a negative exponent, right? But what kind of polynomial is this?
Constant?
Yeah. It's a constant monomial, right? And we should know that by now. We get rid of the variables. It becomes a constant. It's always 1/5, right? Monomial. Does that make sense? Now, if we have something left in the bottom, it will not be a polynomial. Does that make sense? Right? Anytime you have something in the bottom, no longer a polynomial. But if we get rid of everything in the bottom, it turns into a polynomial. Does that make sense? Okay. This one, factor. It's all about factoring. So, first step, GCF. Can I pull anything out? What goes into 3, 3, and 18? 3. 3 times what is 3? 1. Okay. 3 times what is 3? Okay. 3 times what is 18? Perfect. Okay. What goes into 3, 17, and 14?
24.
Or whoops,
1.
24. 1. So there's no number, right? No GCF. Okay, good. So we can rewrite this. 3 times m squared minus m minus 6 all over 3m squared minus 17m plus 24. Now, taking you to the next level. Because at this point in the game, we should be better at our factoring. Okay? We need to know how to factor, especially 3-step method. How do I know this is a three-step method? Because there's no star. And if there's no star, right, then there's no star cleanup. And that gets rid of all that. Now this is technically a four-stepper because we did the first step, right? But now it becomes a three-stepper. We're done with the GCF, so there's no GCF, there's no star, and there's no star cleanup. So it's really, really easy. What multiplies to be 6, but subtracts to be 1, right? That's how we need to look at these every single time. What multiplies to be 6 but subtracts to be 1. It tells you this every single time. I mean, we should get used to it. So what multiplies to be 6 and subtracts to be 1? And then the other thing is, break it up. Right? So we have M and M. And then we have our signs. First sign. Second sign tells me that they are different. Right? So it has to be plus. And then you're telling me 2 and 3 or 3 and 2. Which one comes first? 3. Big number first. It's really important. So 3 and 2. Right? And so that's done to the top. And we're going to do the same thing to the bottom. Right? Now the bottom, we might want to take the steps because this is a 5-stepper. 5-steppers are a little harder. So do the whole 5-step. First step, GCF. Right? Second step, star variable. Okay, so I'm going to go like this, and I'm going to go 3M, 3M, and then down here, I'm going to remind myself that I've got a 3, so that's a 3 and a 1, has to come out later. Okay? And that's that star cleanup part, right? So for 5 is star cleanup. Okay? And that's the cleanup, taking out that 3 later on. Now, what's my third step? Signs, very good. So if you don't know it, this needs to be in your cheat sheet. So signs, and then that means this first sign comes down. And the second sign tells me that these are either the same or they're different. Is it a sum or is it a difference? Up here it was difference, so it is different. Right? Down here it is a sum, so they are the same. That means these two are the same, so it has to be minus. Does that make sense? We're good? Okay. So then, we got to do product and sum. Okay? So the product is the first times the last. Or 3 times 24. Which is a lot. 72. Okay? I'll trust you. Hopefully we didn't do it right. Didn't do it wrong. Yeah, that's right. Okay. And then the middle number, that's the sum. Okay? I'm going to do that in a different color just for giggles. So 17 is the sum. Right? And in the sum, we are adding. So we need 2 numbers to multiply to be 72, but add to be 17. 2 numbers that multiply to be 72 and add to be 17. Now here's the thing. I might need to break it down. 12 and 5, he says. Okay? So, but some people might not be able to figure that out, right?
12 and 5 is 60.
12 and 5 is
Isn't it 60?
60? Yeah. So 12 and 5 is 60, not 72. 6 and 12 would be 72, right?
Maybe.
So here's what I would do. 72, I would break down. 2 goes into 72 how many times? 36. 2 goes into 36. 18. 2, 9, 3, 3, and 3, 1. Okay? And what that does is it sets up, I'm gonna erase this problem, and we'll do this problem next. So it sets up all the numbers that are possible. So 8 and 9 would be how much? So right here is 8 and 9, right? So 8 times 9 should be 72. But they add to be, 17. Was that? I didn't mean for that to work. But, okay. So that's the one that works, right? I always go with the top versus the bottom first before I start picking and choosing weird combinations. Does that make sense? Kind of just go, okay, where am I at? And then how can I get closer to 17? Right? So I'm looking at, okay, 2 times 2 times 2 is 8, and 3 times 3 is 9. 8 times 9 is 72. Okay, 8 and 9 is 17. That's what I'm looking for. So what goes in first? 9 and 8. And then comes my star cleanup, right? And it tells me I've got to take out a star. So does 3 go into this side?
Yeah.
And so I put a star by that 3. Okay? And does a 1 go into this side?
Yeah.
And I put a 1 and a star by that 1. Because I'm taking them out. But I'm throwing that away. See, I didn't throw this 3 away. So I'm trying to make sure that I sometimes, in this case, I got to throw this away. This 3 gets thrown away. So you see the difference? This is still part of the problem. This 3 helped us do the problem. It gave us a little bit easier math. And so we just pull it out. We get m minus 3, right? And we get 3m minus 8. Okay? And so what I'm left with, let's clean it all up. So I have 3 times m squared, no, not m squared anymore. 3 times m minus 3 times m plus 2, right? That was the top part. Okay? And then the bottom part was m minus 3 times 3m minus 8. Okay? And so with this, before I cancel anything out, I need to know that this cannot be 0. That means if this is 0 and this is a number, then it's 0, right? So m minus 3 cannot be 0. And if this is 0 and this is some number, it still equals 0, right? So this cannot be 0. And the reason is the bottom of a fraction cannot, and students in pre-cal still asking me, why can't it be 0? Because the bottom of a fraction cannot be 0. Okay? It can't be 0. And they're like, why? Because it won't work. Because your computer can't calculate it. Because we don't know how many times 0 will go into something. Well, why? Like, they stuffed my shoe in their mouth. It's just like, at some point, you're like, at some point you have to just accept the fact that something doesn't work. Right? Okay? Why do I shock myself when I touch the plug and I plug it in? Because electricity is coming through. Why? I'm going to stab you. Okay? So just accept it and don't do it, okay? So here I got m cannot be 3, right? And that should be guaranteed by now. We should just know that. And then here, you can do the math, but we should get better at this. Remember, it's always m is equal to, or not equal in this case, the opposite of this over that. So it's 8 over 3. But if you want to go through the, well, 3m minus 8, so I'm going to add 8 to both sides. So I get 3m cannot be 8, and then I get divide by 3, divide by 3, and so now I have m cannot be 8 over 3. Fine. Next year, I'm flicking you in the ear every time you work it out instead of just doing it in your head. Because you'll be in pre-cal or college and you need to wake up. Okay? It's a pattern. Know it. Because you got to get quick at this. These are the things that slow you down. Simple things. Right? So it cannot be these two things. Right? What else? Now what? The hard part. Cancel what's alike. What's the same on the top that's on the bottom? N minus 3, N minus 3. Okay? Nothing else can cancel, so I have 3 m plus 2 over 3 m minus 8, whereas m cannot be, and then I put those in order. What's bigger, 8/3 or 3? 3. So we go 8/3 and 3. And that is your answer. Okay? That's it. How much time we got?